And here goes our first example. Y is equal to 3 cosine of x. So let's first find our amplitude and period. The amplitude, the absolute value of A, is equal to 3, and the period is 2 pi divided by the coefficient of x, which is 1, so 2 pi over 1, or just 2 pi. And that means that the quarter period is 2 pi over 4, or simplified pi over 2. Now let's label our coordinate plane. 4 boxes is pi, another 4 is 2 pi, another 4 is 3 pi, 4 to the left is negative pi. And 2 steps up is 1, another 2 steps up is 2, another 2 steps up is 3. You will see why I did that in a second. 2 steps down is negative 1, 2 steps down is negative 2, and another 2 steps down is negative 3. Also, let's remember our memory trick. This is a cosine function, so this is holo. And now we're finally ready to plot our 5 key points. But now let's remember that the amplitude is 3. That means when we used to use the point 1, we now have to plot 3. When we used to use the point negative 1, we now have to plot negative 3. So starting at the high then, we start at positive 3. From there we go down to 0 at pi over 2. Then we go to the low, which is at negative 3 because of our amplitude. We go back to 0 and back to our high. From there we go back to 0, back to our low, and to the left we would get back to 0, back to the low, and back to 0. Now I'm going to graph the part that spans our first period with a solid line. And from then onwards, just with a dashed line, like we did it in the first tutorial. And remember, this is not a straight line and doesn't lead to a zigzag. This is a curve. And here is the graph of our function y is equal to 3 cosines of x. And now let's write down our domain and range. The domain curve goes on to negative infinity and to positive infinity without interruption. The domain is therefore all real numbers. And the range is dependent on our amplitude. So our greatest value is 3, our smallest value is negative 3, and that will be the range. And both values are part of the range, therefore we use brackets. Let's move on to our next example. Y is equal to 1/2 cosine of x. First we're going to find our amplitude and our period. The amplitude, the absolute value of the amplitude is 1/2, and the period is 2 pi over b, which is again 1, so the period remains 2 pi, and that makes the quarter period again pi over 2, and this is what we need to know at which intervals to place our 5 points. Let's label our x and y axes. Pi is at 4 ticks, then 2 pi, another 4, 3 pi, another 4, 4 pi, another 4, and 2 steps up is a 1, another 2 is a 2, 2 down is a negative 1, and another 2 is a negative 2. This is a cosine function, so again our code word is holo. And now we're ready to plot our points. Our amplitude is 1/2. That means our highest value is going to be at 1/2 instead of 1. 1 times 1/2. Pi over 2 over to the right, we get to 0. Then we get to a low, which is negative 1/2. pi over 2 further to the right, we get back to 0, and then at 2 pi back to 1/2, and the periodic continuation of the points is like this. Graphing our first period in solid and the rest in dashed line. This is our graph for y is equal to 1/2 the cosine of x, and our domain and range. Domain, and by now I'm sure you have realized that the domain for any sine and cosine function is always all real numbers, and the range for either of them is always dependent on the amplitude. So the range goes from -1/2 to +1/2, both values included. On to our next example. Y is equal to -2 cosine of x. Our amplitude is the absolute value of -2, which is 2. Our period is yet again 2 pi over 1, which is just 2 pi, and that makes our quarter period pi over 2. This is another cosine function, so holo is our memory trick to place our points. Now let's label our axes. Pi, 2 pi, 3 pi, 4 pi, 1, 2, -1, and -2. And now we can start plotting our points. But wait a minute, our A is actually -2. Now for the amplitude that doesn't make a difference. However, the negative sign flips the way we plot the points. It flips the entire graph across the x-axis. So instead of starting at our high with our +2, we start at the low with -2. From there we go to 0, to the high, to 0, and back to the low, and keep going periodically like this. Now I'm graphing our first period and the rest of the graph. So really what a negative sign does, if you want to think about it this way, it turns holo into low hole. Okay? So that's what the negative sign does. It flips the graph across the x-axis, but that is something that we have seen with all other function families already too. The domain is all real numbers, and the range goes from -2 to 2. On to our next example. Y is equal to the sine of 2x. Now we finally have our first sine function and also our first function where b is not equal to 1. So now let's see what that does for us. First we're going to find our amplitude. The absolute value of the amplitude is 1. Our period now is 2 pi over b, and b is 2. That means our period now becomes pi, and that makes our quarter period, when we put each of our points, pi over 4. The mnemonic or memory trick for our sine is O holo. And now we are ready to start on our graph. First we're going to label it the same way as always. Pi, 2 pi, 3 pi, and to the left -pi. Up 2 is 1, up another 2 is 2, and down -1 and -2. And now we're plotting our points. We start at 0. Then after a quarter of pi, we go up to 1 to our highest value. Then we go back to 0. Then we go back to the low and back to 0. And we can continue doing that for the entire interval that we have here on our coordinate plane. So let's graph it. This is our full period, just pi, and here goes the rest, periodically going up and down between our highest and our lowest values. Our domain is again all real numbers, or in interval notation we could say from negative infinity to positive infinity. Our range is from -1 to +1. Now our period was only pi instead of 2 pi, which made all the waves go much closer together and the values oscillate much faster between the low and the high than in the previous case. And now let's look at our next example, which is going to be different. Y is equal to the sine of 1/2 x. Our amplitude is again 1. Our period is 2 pi divided by 1/2. What is 2 pi divided by 1/2? If we divide by a fraction, we multiply by the reciprocal. 2 pi times 2 is 4 pi. And that makes our quarter period 4 pi divided by 4, which is just pi. Since this is a sine function, we have another Oholo pattern ready to label our axes the same way as we have been. Pi after 4 boxes, 2 pi, 3 pi, 4 pi, 1, 2, -1, -2, and we're ready to put our points starting at 0, and then after quarter period, which is pi, we get to a high. After another quarter period, 2 pi, we get to 0 again. After another quarter period, we get to the low, and after another quarter period, we get back to 0. So this is one period, and then continues to both sides until infinity. The domain, again, from -infinity to +infinity, and the range from -1 to +1. But what's different this time, again, is the period, and this time, as we had a b which is smaller than 1, the period got larger. So let's move on to the last example of the day. Y is equal to the sine of 3x, and this is one of the rare exceptions when we will label our graph differently than we have been doing, and I'll show you how, and I'll also tell you why. But let's get started and find our amplitude first. The amplitude is 1. The period is 2 pi over 3. And that makes the quarter period 2 pi over 3 divided by 4. And 2 pi over 3 divided by 4, or if you want 4 over 1, is the same as 2 pi over 3 times 1/4, which makes it 2 pi over 12, or simplified pi over 6. The quarter period is pi over 6. Now pi over 6 we weren't able to plot very nicely in the coordinate plane before when we had pi divided into 4 boxes. So therefore in these cases we are actually now going to make it 6 boxes to get to pi, which makes each one box be pi over 6. So that's how we're going to label our coordinate plane now. After 6 boxes this time, we're going to get pi. After another 6, we're going to get 2 pi. No need to change anything on our y-axis. 1, 2, -1, and -2. This is a sine function, so our pattern is holo. So now we're ready to plot our points. We start at 0. Then after 1/4 period, which is pi over 6, so just 1 box over, we get to the high. 1 box more, we get back to 0. 1 box more, we get to -1. 1 box more, we get back to 0. And we could continue that, and we just continue for 1 more period like this. And also to the left. And now let's plot our first period with a solid line, and the rest with the dashed line again. As we can see, it takes 4 steps to get through one period. That is 4 pi over 6. Each step is 6. And that is simplified 2 pi over 3. And that is exactly the period that we had calculated. This is one of the exceptions when we have to label our coordinate plane differently than our standard case where we use 4 boxes for pi. Because if our period has a denominator of 3 or 6, then having to make those marks between grid lines would make the picture rather messy. All right, so much for now, and I will see you in class.